glass in this, and I'm sure everybody will agree to that. Then first stage was to convert this garbage into something that is not harmful. If we burn the garbage, there is going to be oxidized harmful gases. So we decided to do pyrolysis work. And by pyrolysis, our process was to totally carbonize all the carbon present in our garbage. And whatever little trace metals in the garbage, like in fruits or in vegetables, that can be also percolated down into that carbon during carbonization. And then there was a question of still there will be fumes and gases coming out. So what we thought, what to do with these? They were not oxidized, but still they could have been harmful. So then we thought of sending it into another furnace. We call it CVD furnace, which is a very well-known furnace for the carbon nanomaterial and other nanomaterial synthesis. So we slightly modified the design of that, and then we connected it to our first furnace so that all the gases go there. And there we put another nano catalyst. So in the first furnace also, the whole reaction was taking place because of a furnace. Parameters important were furnace, temperature and pyrolysis, that is burning in absence of oxygen. Here also same things were there, but temperature was different, and condition was pyrolytic here also, and we had a very different catalyst here. All these catalysts were nano catalysts, and I must tell you why we use nano catalyst. One thing is that nano catalyst, anything in nano form, anything you receive, you review it or reduce it rather. Suppose I have got this ball, and if I cut it into two pieces, then it has got two more surface area for reaction. So anything when you chop, it's like tea powder. You take leaf, you have to put more tea leaves. But if you take tea powder, you have to put less. So that is one, very basic thing about the nanoparticles. But the nanoparticles that we are talking about are very specific structures in the range of 1 to 100 nanometer. They have entirely different properties which you get in their bulk material. So iron, as the properties of iron and the properties of iron nanoparticle are entirely different. Many nanoparticles, they become magnetic. Gold becomes magnetic, which is not, but it becomes magnetic when it is of very small nano size or nano structured. So this our work, I think the main brain behind that was developing a nano catalyst that can convert all the carbon that is coming, because carbon was the main polluting material there, all the carbon that was coming there into a carbon nanomaterial. Carbon nanomaterials are very good materials, and they are having a lot of application in today's society. People are working in the healthcare, in solar cell, in fuel cell, in supercapacitors, in microwave absorption. The American planes are coated with a special type of carbon nanomaterial. That nanomaterial that plane can go in the enemy territory, bombard there, come back without being noticed. So that is just to show you that these nanocarbons have a lot of great properties. So we get some nanocarbon formation also. And whatever little gas comes out, mostly there will be oxygen and nitrogen. Still, if there is something else with it, we pass them through water having a particular pH. So this is the whole system in a nutshell, and without going into much technical details, I have just tried to explain it to you. But we have been very thoroughly through every stage that we don't create any non-eco-friendly material.